Alright, so we are going to continue from where we stopped in the blending model problem we have been solving. So we've been able to create a table, we've been able to write the variables, determine the cost function, and also create the constraints. So we want to now use the graphing methods to solve it. Now remember the steps to follow. You create the graphs corresponding to the constraints, and then determine the feasibility region, and then impose all the graphs together. So let's move on to the next slide so that we can actually solve this problem. All right, so these are the constraints, and we want to plot a graph corresponding to the constraints. Remember that we also have one constraint called the non-negativity constraint that says, let me take a white pen. The non-negativity constraint, let's call it right, so it says x and y should be what? Should be greater than or equal to 0, and let's call it C4, and that is a constraint. Permit me to also write out the cost function, because so that we'll be looking at it as we work. Function f of x and y equal to what? I think 8a plus 10b, right? Okay, 10x plus 4y, 10x plus 4y. So we want to minimize this. Already you know that all the constraints, we have this non-negativity constraint, means that if you have the xy axis, let me just assume that we have the xy axis, it means that this is the path it will go, because this has to be non-negative. So let's forget about the constraints for C4. So everything we are going to be doing about all of the constraints should be in the first quadrant, that is in this part of in the positive part of the xy axis. All right, so let's take C1, which is this one. All right, so let's try to sketch it. Okay, let's also, okay, so C1, so let's say this is x, this is y. So we are trying to find the intercept on the x-axis and intercept on the y-axis. So intercept on the y-axis is at a place where x is 0, right? Good. So to find intercept on the x-axis for C1, for this equation here, you have to set x to be 0. So if we set x to be 0, so x disappears. So what we'll have is 2y is equal to 60, and then y is equal to what? Is equal to 30. So let's say the intercept on the y-axis is 30. So let's plot it here. On the x-axis, what you'll do is simply set y to be 0. So what you have then is 3x is equal to 60, and then that gives you x to be 60 over 3, which is 20, right? Are we missing out anything? I don't think so. So here is what is 20, and here is 30 for y. I hope you are following. If not, just pause the video and then see what you can do. So let's join the two lines together. I hope I'll get it this time. Good. So since we are considering greater than or equal to, it means that it has to be, this is the feasibility region. It has to be above the line for it to be greater than. So let's plot the next graph, this time for C2. So for C2, I hope this is clear. So here we have what? We have 7x plus 2y is greater than or equal to 24. Intercept on the y-axis, you simply set x to be 0, and that will give us what? It will give us 2y is equal to 84. And that gives us y is equal to what? 42. So when we set to get intercept on the x-axis, what do? We set y to be 0, and that will give us what? Will give us 7x equal to 84, and that will give us x value of that should be 12. Yeah, and that will be 12. So somewhere here, 12. So if you divide 84 over 7, you get 12. So let's join the line together. Hope I can get it straight. Yeah, good. So since we are talking of greater than or equal to, feasibility region should be above the line. I hope this is clear. So if we go for C3, which is this equation here, so let's try to sketch it out. So what do we have? We have y, we have x. Intercept on y-axis, we place x to be 0. So we have 6y equal to 72. That will give us y to be equal to 42. 72 over 6. 72 over 6 is going to give us 12, right? So it's going to give us 12. So that should be somewhere here, 12. So in case of the x-axis, we set y to be 12. So we have 3x is equal to 72. So 72 over 3, I think that should give us 24. 24. So we join, and that is it. Alright, so we're on track. So the next thing is we combine everything, combine all graphs. So let's draw a larger graph that will combine everything. So go down a bit, so go this way. So for the x-axis we have, sorry, let me put this little cap here. For the y-axis we have 42, we have 30, and we have 12. So let's start with 4, 2, we have 30, and we have 12, right? Good. I think we are getting it. Okay, for the x-axis we have 20, we have 12, we have 24. So let's start with 12. So this is 12, and this is 20, and this is 24. So for C1 we have 30 is to 20, so drawing from 30 is to 20. Hope I get it straight. Okay, not very straight. For C2, which is this is C3. For C2, we have 42 is to 12, so we go from this place, we go down, 42 is to 12, okay, fine. And for the last one, we have 12 is to 24, so let's see, so draw 12 all the way to 24. So the feasibility region should be above all the lines. So as we said before, we have the points that correspond to the boundary, to the feasibility boundary. I'm going to mark them out because this is something you need to know. Let me use a red pen this time. Yeah, so we have here, the boundary, we have here, and we have here. All right, good. So now, so the solution to this will be either of these. So we need to calculate the value of the cost function in all these positions, and then we'll be able to get the lowest one. So what to do or how to do it easily is to create a table to be able to do this. So we need to tabulate. We need to tabulate it. So we create a table like this. Let me take a white pen. So we need to create a table like this, and we say points. So we have the first one, let's call this P1, let's call this P2, let's call this P3, and call this P4. So just say P1, P2, P3, P4. This is F, and this is what? This should be X, Y. So for the first point, we have 42 as Y and X to be 0. So it's like we can say the point for P1 is 0, 42, right? Good. What of P4? P4 will be 24, 0, right? 24, 0, right? Good. So what is left now is to find the values for P2 and P3, right? All right, so I'm going to switch over to the next tutorial, which is tutorial 8. For now, I like to try to give you a little homework to try to figure out the values for P2 and P3 and also calculate the value of the cost function for these positions. And then in the next tutorial, we are going to clarify all of this. I'd like to thank you for viewing. Remember, if you've not subscribed, subscribe right now so that you get notified when I make new lessons.